Hey there, this is Drew Jones, and just following up for that really great meeting that we had the other day. So, this is for Jules and Paul and Bruce and John and others on your team who we got to talk together with, and maybe on to some other folks. I've had similar conversations there at RMI. Lena and Kieran and James and Ethan and Katie. And I'll trust you guys if you want to send it to Amory and to your board. But for now, just to recap one scenario or several scenarios that we made that really address this question of the timing of reductions by 2030. There was talk of the goal of reducing emissions 45% by 2030, and talk of is it time to pull the goalie? So I wanted to look at this and not think about the extent of reductions, but the timing. When do different things kick in if we really are serious about this 2030 goal? And the scenario that I created is something like this: is here we are with the business as usual that's, as I said, is calibrated to somewhere between RCP 8.5 and RCP 6.0, and really following the integrated assessment models for SSP2. Look at particularly the green line for renewables. Now, if we really both encourage them so that they grow much more, both through global action and subsidies, but also through, say, a storage R&D breakthrough, maybe other cost breakthroughs. I've created a scenario with really high growth, and it's growing, you can see right here, very, very fast, up to the point by 2050, it's about 400 exajoules, 800 by 2100. So remember those two numbers, 400 and 800. And we're going to compare that against, first, the business as usual, where we were at a little less than 100 and 200, and these are the other integrated assessment models under their baseline. But I also made a graph of the low emissions scenarios. So the low emissions scenarios, Shell Sky was a little south of 300, 600. I'm really hoping to get the Bloomberg New Energy Finance number, but remember what we just said was 400 right here by 2050 and 800 way off the chart. So the scenario is well above what anybody is imagining. I'm not saying it's impossible. I'm just saying if we don't get the results that we want, it's not because the growth isn't fast enough. So there's super fast growth in renewables. And the question is, how good a job does it do at keeping coal and gas in the ground so that emissions go down 45% or a lot by 2030? And you can see right there's coal coming down in 2030s and coming down in gas in the 2030s. And so emissions really start coming down in 2035. So the thing I want to point out there is just this baked in delay between the actions, even super aggressive growth, and the emissions coming down. So if we want to have reductions by 2030 of any scale, we need to do more. Now, one kind of more, Amory mentioned several times, more aggressive energy efficiency. So when we look at that, if we're not improving at 1.2%, but if we're improving at 3.3% or 4.9, you can see over on the right the energy intensity of GDP falling. That's going to, in the same way, in the long term, really reduce those emissions. And of course, we need a lot less wind and solar. But it's really not changing the year, a little bit, the timing of when it kicks in, when we get those reductions. It's still out in the 2030s. This is why I was so encouraged to hear what you told me about, is that you're starting to think about the pipeline. And the pipeline, of course, is all that's in the pipeline in coal that is then coming online and emitting in the 2020s up here through 2030 in this scenario. As I showed you before, there are two things that we can test in En-ROADS. One of them is stop building new coal infrastructure. Say in 2025, you see it come down. If it happened next year, even better. But of course, the actions that could find the public policy measures or the market incentives that you discussed briefly to reduce coal utilization sooner. So watch there as we have a 19% reduction in coal utilization, 53. And then when you start imagining these kinds of scenarios, those are the things addressing the supply line of those plants is the thing that gets those emissions to peak out here in the 2020s and start falling. In this case, a reduction by 2030 of something, not 40 to 45%, but a reduction. So the key thing, though, is that by addressing them directly as a complement to alternatives to fossil fuels, such as renewable energy, wind and solar, and energy efficiency, addressing them directly, then we actually get that peak a little bit earlier. That's just a little, wanted to make sure that point landed. It was such an intense time of trying to show the scenario in the middle of the big meeting. But there's a little summary of it, and if it'd be helpful, I'd love to work with you all to set you up to run these scenarios. Already, Kieran and Ethan and Katie and James, you guys have done a great job of playing with the model. If you want to play with it more, let me know how I can help. And keep up the great work. You really are some of the best that I see out there, and I'm so happy to have been brought into this meeting and have the chance to think with you all about the dynamics of addressing climate. Bye-bye.